Hey everyone, welcome to the Simbot seminar series. Tonight is episode 6, and we're going to be talking about the FRC beta control system. This is a series of seminars put on by Team 1114 to help, give information out to the FIRST community, and we've covered a lot of different topics. We've covered strategic topics, we've covered scouting, we've covered mechanical design, we've covered the Chairman's Award, and this week we wanted to cover our experiences that we've had with beta testing the new FRC control system that all teams are going to be using in 2015. So now I'd like to pass things off to our FRC control system experts, our lead programming mentor and co-lead teacher, Mike Duramio, and our two team presidents, Caleb Dodd, and Gavin Black. Take it away, guys.
Hey, guys. We're just going to get right into the presentation here. This is Caleb and
Hello.
Gavin. I'm Michael. Yeah, let's get some recursion going. Sorry, just one sec. All right, here we go. Just some introductions. My name is Michael Duramio. I've been involved with Simbotics for 9 years now. I'm a computer science graduate from Waterloo, and I teach here at Governor Simcoe Secondary. Gavin and Caleb are our two team presidents or team captains this year. Gavin's been the driver for the past 2 seasons, and is the head of our mechanical and electrical sub-teams. And Caleb is our head of programming this year. All right, so tonight, this is mainly going to be an overview of the new control system and about our experiences with it. So we're going to start talking about what the beta test is all about, and then go over each component, and then a little bit about the programming changes that you're going to see this season. So applications were submitted for the beta test last May, and over 200 teams applied. We were selected as one of the Java beta test teams, so that's what we're going to concentrate on, is the Java environment and Java code. We got the control system mid-August, and there were a series of goals that we had to accomplish. We're on step 5 out of 6 right now, but basically testing the components in a benchtop test, and then on our robot, acting as ambassadors for FIRST and the new control system, and serving as experts in our areas and at events that we're at this year to help teams out during build season and during competition season to make sure things go smoothly with the transition. We have to hold a control training seminar. So this is one of them. We're also going to be at SWATposium on November the 15th in a few weeks, if anyone's in the Oakville area. So, as I said, we started off with a benchtop test of the control system, just basically hooking up all the components, learning how to wire it, hooking up to some motors and sensors and seeing how it worked. We then installed it onto our 2014 robot and ported our code over to the new system. We've been reporting back every few weeks to FIRST with a progress report about how the tasks are going, and discussing feedback with them, things that we've discovered with that are issues. And as we said, acting as ambassadors and being experts. I got confused myself. Here we go. All right, so far we're now done our benchtop test. We've posted some pictures on our Facebook site about the full test and a series of YouTube videos going over each component. We've ported it over to our robot evolution, the code's over on it, and we competed a few weeks ago at Cha Ruckus, which was a fantastic event. If anyone made it down to it, we had a great time. And it was good to get the robot on the field and see how it did in actual matches. What we have left to do, we have some code to publish still. There's been a few changes that have happened as the library progresses, so we've got to iron out some kinks with it still before we get it up and published. We have, as I said, the presentation coming up in Oakville on November 15th. We have some stress testing left to do. We'll talk later about the brownout testing, but the things like reversing the polarity and things like that we wanted to wait until later to do, so we didn't fry anything early on. Speed controller testing, we had a limited quantity of the new Victors, and we're still waiting on the Talons, so we haven't had a chance to do that testing yet. Vision code, we used the NI Vision library for the past few seasons, and when we first ported the code over, there wasn't any vision support, so that's still going on. And in the new system, we'll talk about this a bit later too, but there isn't support for the connect through the driver station anymore, so we're looking at alternate ways of getting that feedback over to the robot. Things were not, just some misconceptions about what the beta testing is. We had nothing to do with the actual creation of the control system hardware or software. We have no decisions or no power on whether the switch should happen or not, or what the switch should be to. We do not know much at all about LabVIEW, and we haven't programmed in C++ for robots much. And we are not part of the GDC, so we have no say in what gets included in the kit or what game rules about legality of parts of that. And we're also not allowed to distribute any of the current documentation that FIRST has created. This is because they don't want beta versions of this floating around and causing confusion. So you won't see it, like we'll strip this sort of stuff out when we present our materials and our code. All right, the new control system. This is our benchtop test of the new system, everything wired up and running.
I'm just going to interrupt for 1 second. In case anyone has any questions, this week we're going to be doing questions live on the fly. So if you have any questions, feel free to post them in the Google Hangouts Q&A app. That's the easiest way to get them to us. If you don't have access to that for some reason, you can tweet them at us or post on our Facebook page.
Sorry, I was supposed to mention that right off the bat. Whew. Here you go. Yeah, and Karthik, if you could just send those into the chat for us, we can keep it out there. So here, here's the overview of the whole system. A lot of the components look similar to what we've seen before. The nicest change of it is the integration of so much more of it into the main robot controller. Some frequently asked questions that have come up as we've kind of gone around at Ruckus and people asking us questions. First of all, how similar is the code? It's very similar. Porting our code over involved changing, like reducing port numbers by 1, and the majority of it just worked. Compared to the last test, this was a very small change compared to when in 2009 we went from C to C++ or LabVIEW. Where's our code? Still not up yet. We've got to clean it up a little bit. The radio is, we've been using the same radio as was used last season, 2014. I know that some alpha teams were testing out some dongles last year, but we weren't given any of that. The new system seems lighter, but we were too excited to get it mounted onto our robot, so we didn't lay it all out and weigh everything compared to a Creo, so we're really sorry for that. And Ruckus, there's been some discussion on Chief about why our autonomous was so terrible at Ruckus, and this is more about our robot starting to fall apart after a long competitive season. Instead of any actual issues with the beta test hardware or software. We had it working fairly reliably before we went and just kept taking more damage. So sorry about that to all of our partners, especially knocking our partners' ball out in the finals. But we had a great time, and but the software's held up pretty well. Some new names for things, so we just kind of threw them all on a slide here for everyone to see. The Robo Rio's the main controller. It's called a power distribution panel now instead of board. There's a separate pneumatics control module that's a standalone part instead of a breakout on the main part. The voltage regulator this year has a few more outputs in that. It's called the VRM. The MXP is an expansion port in the middle of the board. We'll talk more about that later, but it allows you to get more than the actual output. We have a few questions in the chat we'll get to in just a second. We'll have a picture of the Robo Rio up in a second, and we'll get to them. The multicast DNS, MDNS, is new this year. Instead of the robot having a specific IP address, it has a name, which makes things a little easier to deal with. And then we've got the 2 new speed controllers coming out this year, the Victor SP and the Victor MXP. All right, here is the Robo Rio. There's a lot of pictures of it floating out there. This is our lovely benchtop picture of it with our wood background. There's a lot of ports on it. There's a question in the forum we're going to get to, or in the Q&A right now. What connector is used for CAN on the new Talons? We don't actually have any of the new Talons yet, so the only information we have is what's out there already on vexrobotics.com, and it looks like it's similar to the 2 Victors that we have, where it is a 4-wire PWM style cable coming out of it that you would just put in line with the rest of your CAN. And a second question in it, What part of the robot is that board?
The board is not a part of the robot.
Oh, this was just our benchtop test. So we just screwed everything down onto a piece of wood we had lying around and put on top of a cart just to make it easy to deal with for it. But yeah, this isn't part of our actual robot. Our connecting for electric components onto our robot is almost exclusively done with Velcro onto our sheet metal base.
I'd like to make a minor correction. It was actually a cupboard door that you used.
Yes.
I was trying to make us sound more professional by not telling them how much we use cupboard doors in our prototyping and development. But
I just put it all out there for everyone.
All right, so a few changes from last year. Like, as I said, the number one thing is that so much more is integrated directly into the board itself. Instead of having breakouts on top of modules that plug into the Creo, you have all of your digital I/O, PWMs, relays, analog outputs, all built into the directly into the board. There is a bit of a shortage this year with that form factor, that they only give you 4 relay and 4 analog outputs directly accessible. But that's where the MXP, the expansion port in the middle of the board, comes in. Those pins in the middle of it provide you additional PWM, relay, analog outputs. And we haven't used it a great deal. We've just wired some analogs into it for some sensor logging, but it seems to be pretty straightforward, and a lot of teams out there have started developing boards for it. All right, another question. Are there any components of the new control system that you cannot directly mount to a conductive material, like the Creo would short out when you did it? No, the new stuff has nicer casings around it. There's a plastic casing on the Robo Rio. We haven't done a lot of testing yet with the Victors, but they have a metal case, but that's more the heat sink, so it might actually be a good thing if you mounted it directly to the frame to bleed off some of that heat. But no, it seems a lot more robust and less of an issue for teams with it. We're directly mountable. We have it just Velcro directly onto, well, right now on a piece of Lexan, but we did have it on metal before, and it was not a problem. All right. I'm sorry. As I said, yeah, the MXP provides those additional outputs. We haven't gone to it too much, but so far it's worked well for us in what we have tried. It also has integrated a few extra connectors. We've got a USB host on it, plus a USB B port on it. We've been using the USB B port for some programming and connections just when we were doing the benchtop, and also for doing firmware upgrades. And then the standard kind of Ethernet port, which is what we're using to connect to the old radio. There are some other ports on it that we haven't used. We haven't used them in the past, but other teams out there have liked them for sensors. The I2C port, SPI, RS-232. And there is a built-in accelerometer, but we haven't gotten a chance to play around with it yet. Yeah, as I said, we found it a huge advantage to have it all in one piece as opposed to all the separate little points of failure we had last year. And it was really easy to get wired up and running. Some things that we've noted going along, again, we didn't really quantify this, but noticeably faster boot times than the Creo, especially on a code reboot before matches, and that just made things a lot smoother. We had our gyro spinning one match, and they didn't even really seem to mind that we had to reboot it to get things settled down. Went pretty quickly. Unlike the old system, there's no built-in restraints for cables, like the PWM cables. But we always find it good practice to put a little bit of goop on each one to kind of hold them in place, and that seems to work better than the restraints anyway. We found with a lot of the restraints, you end up just ripping cables out.
One comment on the goop: we don't necessarily know that goop, if it will be legal or not. For a long time, teams used to be hot gluing their PWMs in, and it turns out that was illegal without teams even knowing it. So make sure you read the rules very carefully, and if you have any doubts about things like this, that you ask them on Q&A next year.
Bigger pin spacing, so instead of all the pins being jammed together, there's like a gap of 3 header spaces in between each one, which makes it a lot easier to know which cable you're ripping out or putting into your robot. And we've talked about this, but I'm just going to keep bringing it up, that it was like just having everything integrated just made things much easier to deal with. The RoboReel has a web server running, which is used for firmware updates, and it can also be used to check the status of your power distribution panel outputs or your pneumatic module outputs, and see everything on your CAN bus. And it was really easy to use and connect to, and get that information to debug things.
Yeah, it also had stuff like a file browser and stuff.
Yeah, sorry, I don't know if you heard Caleb there. He's kind of quiet, but he said that. Oh, good. Okay, he's listening to himself. All right, connectivity. There's lots of options of how to connect to your robot this year. As we said, the standard kind of Ethernet system we've used before, built over wireless, but the USB is another one, just a nice easy way to plug into your robot and do updates to it or coding on it. Really simple plug-and-play sort of thing, which we found made it really simple to not think about or if you're in a rush to do. Question from the Q&A. What gyro are you testing with? We've been using the kit gyro for the past few seasons, and it seems to be doing well. We used to buy our own boards off of DigiKey, but the one we used was discontinued, so we just tried out the kit one, and it's done everything we needed to do. That said, we only use our gyro almost exclusively for autonomous mode, so only that first 10 or 15 seconds. So we don't need the kind of accuracy and lack of drift that other teams need if they're going to be running it the whole match. So we haven't really gotten too far into exploring other gyro options. There's a great chat on Chief about this right now, though, if you're interested. Another question: have you tested any of the 3D printed PWM straight, such as the Wildstings cable magic? We haven't. As I said, we tend to goop our connectors, and that keeps them in for us. We like to keep things simple. But it does look great. If you haven't had a chance to check out Wildstings' blog on the control system, they've got some really good stuff out there with their cable restraints, and also with a bunch of designs for circuits to connect into the expansion port. So you should definitely check out their site and look at those things. But yeah, for us, we try, as long as it's legal, we'll stick with our goop solution going forward. All right, so the MDNS, we talked about this a little bit, but it alleviates some of the issues that teams have had in previous years of forgetting what the IP address is of the robot versus the radio or the laptop and that. Basically, you access your robot as roborio-your team number .local, and it multicasts its own name over a local DNS and makes it a lot easier to actually connect to it and ping it. And this should alleviate some of the problems that a lot of younger teams have trying to keep track of everything and flip their IP addresses around. So that we found is a really handy advantage to it. They have it set up now so your robot just grabs, like through our testing, your robot just grabs an IP address from a DHCP server and can be named anything within that subnet, same with your laptop, and it works fine. The USB connection, there's a set IP that you can use listed there to connect to it over USB, and it functions basically the same. You can ping it, you can go to that in a web browser. Works really well. As I said, they recommend it for all the firmware updates to either the RoboRio or any of the CAN components. Got a question here. What's Goop? Sorry, I just don't have a clue. Goop, it is a electrical person.
It's a silicon-based liquid that hardens within about 5 minutes. We just use it to hold it in. We stopped using hot glue because it was illegal, and the goop peels off pretty easy, but it doesn't just get bumped out. It firms up pretty well, but it's able to be taken off.
Just to address our next Q&A question, thank you, Scott. Scott has posted a link to it in the Q&A. So, James, you can just mark that as read, but if anyone wants to check out a link to it, just check out Scott's question there in the Q&A. So even with all these options, we tested out USB connection, Ethernet connection, but we still, like we did in previous seasons, we do most of our programming over wireless, and we had no issues at all with the new system, running it the same way as we've run in the past. Next up is the power distribution panel, not to be confused with the power distribution board. They look similar, but this one's black. So one of the coolest new features of this system is the connection of the power distribution panel and the the pneumatic control module over CAN to the robot. So both of them have CAN built into them, and the power distribution panel also can be a terminator on the CAN line, so you don't need a special device on it to do that or build your own. We've never used CAN before, so this is all new to us, but it's nice to just have a jumper built into here. If you want it to be your terminator, you just flip the jumper over. So with that, there's built-in current and temperature monitoring on the power distribution panel, so as long as you have it connected through the CAN, you can request that get that information in your code and use it however you want to determine the kind of outputs that you're going to have to your motors. One thing that scared us at first when we saw pictures of the beta test was that there's actually less of the 20-30 amp outputs on this than the old power distribution board. But after we crunched the numbers and looked at what we didn't have to connect anymore without having the breakouts and the digital sidecar and all the little extras, you actually end up, we think, up by 1 as opposed to down by 4. So it actually worked out pretty well. That we're in good shape there. All right, another question here. Does the MDNS handle other IP addresses like RoboReal 1114-camera? Not that we've seen. We haven't actually gotten a camera working in it, so we haven't tried it, but I don't believe that it does. We haven't seen any documentation about additional uses of the MDNS, so sorry about that. If we find out anything, we'll pass it along. Where were we? Oh, just a cough. All right. Yep. So other outputs. The RoboRio has a dedicated 10 amp fuse on it, connected at the very bottom of the screen there, and then there's also a 20 amp fuse shared between the pneumatic control module and the voltage regulator module. So those are the wires you see at the very bottom of the PDP. The outputs along the side, the 20-30 amp or the 40 amp outputs, are the same Wago connectors as in previous years. And on the end are the new Wildmeyer connectors. They work fairly similar. You push down a button, shove the wire in, and then release the button, and they hold really well. We have a little video on our YouTube about how to insert stuff into it, but we found them really simple to get used to. Yeah, we're pretty happy with the new connectors as opposed to the old screw terminals. All right, pneumatic control module. One of the only standalone parts of it, connected again by CAN. Oh, sorry, I should have mentioned on this last slide here about the CAN. If you don't connect the power distribution panel by CAN, it still functions and provides power to your motors or speed controllers and relays. But then you just couldn't get the feedback on your current regulating. So if it came unplugged from the CAN system, you're still okay to function. And on to the next one. Sorry, another question from the Q&A before we move on. Thanks for the questions, guys. This is actually working pretty well. What are the sizes between the new control system? Does it generally tend to take up less space than the old system? Overall, the components are slightly smaller. Like the power distribution panel is smaller. The pneumatic control module is new, but if you compare it to the old digital sidecar, it's smaller than that. And the RoboRio is smaller but has a larger footprint. So that was a bit of an adjustment for us, that it took up less room and weighs less than the old Creo, but you need a larger footprint space to put it into. We actually, in transplanting it, we didn't try to fit the components into the same spot that we had our original control system. we're very good at making our control systems almost impossible to get at because that's fun for the electrical team. So as a demo for this, we wanted to make the system really easy for people to see and view at demos. So we put it kind of up the back of the robot. So we didn't try to cram it into the same spot, but it's definitely a concern to look at, is that footprint of the RoboRio taking up a bit more room. Okay, on to the PCM. So as I said, connected by CAN in the system. And as I said, we also had no experience going into this about CAN. We've always stuck with PWM. It's the simplest solution for connecting speed controllers, and we like simple. But compared to what we saw teams having to do with the Creo of the kind of connectors you needed and making ends in that, the new connectors with the Bild-Meyer ends are really simple to use and attach. One thing we kind of did wrong with ours, though, is that you're supposed to use twisted pair cables, and we didn't have a lot of small cable lying around, so we just kind of stuck what we could in there. So you'll see in these pictures it's not twisted pair, but it's supposed to be twisted pair, and our color coding is a bit off for it. It's supposed to be mostly yellow and green. Oh, actually, sorry, in this picture we don't even have the CAN plugged in. We weren't done yet. Sorry about that. Those are our power lines. They should be red and black. But yeah, 8 outputs on it to solenoids. It's selectable on it. There's a jumper of if you want it to be a 12 volt or a 24 volt output. And one of the nicest features about this for younger teams, like rookies coming in going forward, is that this module completely handles the compressor for you. There's 2 inputs near the top there for the pressure switch to plug into, and 2 outputs for your compressor to plug into. And if all you want is the compressor to go when it is below a certain pressure and turn off when it gets to the threshold, you don't even have to put anything in your code. It just kind of does it for you. You would only add a compressor object to your code if you wanted it to maybe not run during certain parts of the match, like during autonomous, and then kick in during teleop. But they've made it as simple as possible to get that connection going and make sure that it's easy for teams to wire up. So we're really impressed with that, and it works well. Yeah, that's about it for this one. We have a slight concern about the shared 20 amp fuse between this and the other module. We haven't had any problems at all with it, but the compressor in the old system ran on its own 20 amp fuse through a spike, so to have a non-resetting fuse run both of them seems a little odd. But so far, like through all of our testing and through Ruckus, we had no problems with it at all. The voltage regulator module. Last year, the voltage regulator was only for the radio. This one has 4 outputs on it, listed in there. Sorry, actually 8. Sorry, 2 of each of those. We've filled up both of our 5-volt 2-amp ports, one to power the radio and one to power our camera. We have the camera powered up, but no code to use it. Another question from Michael Hill. If using multiple PCMs, does it matter which one you plug the switch and compressor into? We don't really have an answer for that because they only shipped us one PCM, and there's not a great deal of documentation about how to wire it up if you have multiple ones. I'm really not sure how to answer that. We'll have to wait to see once we get some parts shipped to us and we're able to plug multiple ones in. All right, speed controllers. As I said, there's 2 new speed controllers in the works. We were given 2 of the Victor SPs to work with their PWM connector. They are planning to send some of the Talons out to beta test teams. We filled out a feedback form about that a week or so ago, so we're hoping to get some soon to test out. The Talon, from what we've read online, has lots of different options of how to connect it, so pretty versatile. But in the testing we've done, we like the new Victor SP. It's got a nice small form factor. One of the nicest changes for us is that the lights on it, on the old Victors, it was yellow at neutral, no light as it moved until you got to the very extremes, and then at the end it would turn green or red. With the new one, it's a blinking light, and the frequency of the blinks changes as you get closer to full power. Sorry, Kevin. We see your comment there. It does not. I'm not quite sure what that's referring to. I think it's
referring to what we just answered.
Oh, so referring to which PCM you plug it into, so it doesn't matter which of the, if you have multiple, it doesn't matter which one you plug into. Thanks for that. Question from Mark Williams. Have you noticed significant heating or see potential for that to occur with the Victors requiring the use of fans? Because we only had 2 of them, we did some benchtop testing with them, but it's still on our list of things to do is actually get them on our robot permanently and put them under some stress testing. So I'm sorry, we don't have a lot of feedback for the amount of heat that it generates, but it seems to dissipate pretty well in the testing that we've done. I don't know if Karthik wants to speak to that at all and if there's knowledge about it.
Sorry, what was that, Mike?
Asking about heating up of the Victors if people will need fans for them.
No, from what we've seen, it seems that they'll be good to go without any sort of fans, but I can understand why teams want to do them as preventative maintenance, but from everything that, but when I say we, I mean us, the IFI engineers, I think that it's going to be fine to go without a fan.
Another question here, is there any drawbacks from using the new speed controllers? None that we've seen at all yet. It's a nice form factor. I guess the only way the wire gauge, because it's built in, there is a set wire gauge you're using there. But no, they seem really nice, really easy to use, really easy to wire up, really easy to replace if they break. So we're really impressed with what we've seen out of them so far. On to a little bit of the software side of things. There is a new driver station that we've been testing with. There's more logging feedback about your connection with the robot, about packet trip times, about your voltage, robot voltage, all kind of readily available for you instead of having to dig into the logs. They've removed any Connect support from it, and they've also removed the driver station LCD section on it, which is probably the thing we're saddest to see go. We've always used that as our kind of autonomous select indicator of what mode we're in and for our sensor feedbacks, and we find that that was a really nice, quick, easy way easy place to put it. We've moved those things onto the smart dashboard section, but at least with us, we cram a lot of stuff into there, so it was nice to have it separate. There's been no updates to the Java Smart Dashboard yet, but using the previous ones, we haven't had any issues. And we still like the older one, not the FX version of it, so we were running that through Ruckus without any problems.
And, as for the Connect support, and correct me if I'm wrong, Mike, just because there's no support right now, it doesn't mean that FIRST or WPI Lib or them are not working on the background, correct?
Actually, we were told that and everything's fluid, nothing's locked in at this point, but when we inquired about it, it didn't seem that their intention was to add any support for the Connect into it. And we were advised to kind of look at alternate ways of doing it. And there is a really good C# library for the Connect skeleton, and with having full Java available now, it makes it even simpler to get network packets over to the robot. So okay, 2 questions from Twitter. Adam on Twitter. Does the lower current rating of the new Victors versus the old ones concern you? We haven't run into any problems with it yet. It's only, as I said, we haven't had a lot of time to test them out, Adam. Sorry about that. We'll, as we go forward with it, we'll let you know if we have any issues, but we haven't seen it as any issue yet. And a question on here: does Cheesy Vision work on the new driver station? We didn't use Cheesy Vision last year. We had Connect-based code instead. But because Cheesy Vision, or Chezzy Vision, or however you want to call it, it's just a network connection to the robot from a separate app running on the driver station, I can't see it being any issues. It should run fine. There's been some beta test teams that have talked about porting it over, but we don't have any experience with that ourselves. All right, the driver station. Here is our screen full of screenshots, just to kind of give you a feel for the different windows. there's 5 different options for what the left side can look like, and 3 different options for the right side that kind of give you information about voltage, CPU usage, and stuff like that. So similar sort of functionality as before, but just kind of a feel for what it looks like right now. All right, the imaging tool is also updated this year. It looks different. It works a little better, looks a little nicer, but basically the same thing. One thing that's currently a bit of an issue for Java teams, but I think the plan is to have this resolved by the time we get to kickoff, and actually might have been resolved in some of the later updates. We've kind of stuck with what we had before Ruckus and haven't had a chance to look at it yet. But if you're a Java team right now, you have to run the imaging tool to format it with an update, and then you have to separately install the Java 8 runtime on your own. It's a really simple process. It's just a project in Eclipse that they give you, and you just run as Ant project, and it goes. But just another step for Java teams right now that from what we've been told, they're hoping to resolve by the time we get to kickoff. The programming environment. Biggest change is the move from NetBeans to Eclipse. I don't want to get into a battle about which is better. Our team personally loves NetBeans and is sad to see it go, mainly because of the nice color schemes in it, I think, but we'll get over it. But basically equivalent development environments. One nice thing is that it looks like going forward we're looking at the same development environment for both Java and C++. So if you're a Java team and a C++ team needs help, you actually will know how to download and restart their program, as opposed to the Wind River versus NetBeans divide that we had before. So I like that side of it, that we're going forward with a unified development environment for the two. And as far as the code goes, there's almost nothing different. It really looks the same as what we've done before. We got some questions here. What is the imaging tool exactly? Like, what does it do? This was the tool. It existed in previous years too, where you format your, well, I guess before the Creo and now the Robot Rio, and put a new image of the library on it. Sorry, I'm having trouble talking. It's past my bedtime. So it would format it, it would put the updated image on it, and then you would reload your code on top of it. It's been there for the last few years as well for any C++. Actually, I think all 3 teams had to use it. LabVIEW, C++, or Java. Is the dashboard battery graphic based on current consumed or battery voltage level? Voltage level.
Voltage level.
Yeah, it's on the driver station, and it's battery voltage over time.
And you'll see that in both places. It'll be in the chart on the right, and it's also like the little battery indicator will, like the green, there's a red section too, and it'll move up and down with your voltage as you go through the match. Programming changes. As I said before, compared to the switch in 2009 from C to C++, this was almost no change at all. We were actually, because it's off season and we can do whatever we want, we were able to just import our NetBeans project code directly into Eclipse, folder by folder, and had we not changed our package name, it would have been done in about 5 minutes. The same WPI-lib functions are there. It's full Java. We haven't had a chance to really take advantage of this yet, having enums and array lists and templating and all those good things, but it is there, which gives us lots of warnings that we're using things that really shouldn't be used anymore, like vector. Everything's 0-based this year instead of 1-based. This is clearly indicated on the Robo Rio. Everything's labeled from 0 up. Everything will have to just be shifted down one spot. Little things like renaming analog value to analog input so it matches with digital input. And as we talked about, no support for Connect or Vision. The power distribution panel class has been added, and this is really just an accessor to get that current or voltage information from the power distribution panel. And we've talked about this before, but with the compressor, you don't really even need to instantiate an object, you can just do nothing and it'll work fine. Question on the forum, is C++ easier to handle? Easier than LabVIEW for us because we really hate drawing lines. We're a Java team, so far we've exclusively developed in Java and haven't even looked at the C++ library, but from the old days of 2009, they seem fairly equivalent. So I'm not really sure what you're in comparison to what. We've always found Java to be the better development environment because it's what our students learn and because of its exception handling, and that is nice. That at 3 in the morning, it's nice to know what line you screwed up on instead of just seeing segfault. But I think it looks like it'll be easier to actually download and restart your code, that it'll be more like NetBeans of just click one button and it does everything for you instead of having to put the code on and then connect and reboot it manually. But we really don't have any experience with it. We focused on Java. Talked about the compressor. Some of our observations, going to keep saying it over and over, less components is good. Wiring it up is really quick and easy, troubleshooting it, less points of failure. We really are enjoying that new layout and having so much more integrated into the RoboRio. We talked about the faster reboot times on the programming and how quick it was to port our code over. CAN, as I said, our first time ever working with CAN, and it was really simple with those new connectors instead of having to make custom little cables for it. And while we're at Ruckus, we connected fine throughout the competition. We're kind of worried going in, but it went really smoothly, and they were very supportive of us and all the other beta test teams that were there. During that, though, we were still using the old 2010 to 2014 connection code protocol. This is something that right now you can select in the driver station of which mode you want to be in. So we did have the fixed IP on the robot and fixed IP on the laptop, is the same as previous years. So we haven't, though while we've been in our practice field, we have run on the 2015 protocol, and it's been fine. The only real negative, and we've just got one little bullet point here for it, but it's our major concern with where things are right now, is that there's a built-in threshold that if your battery voltage dips around 6.8, it shuts off all of your PWM outputs. The idea being it shuts off your motors to let your voltage come back up and keep the RoboRio from shutting down. In our testing at Ruckus, this did really impact our performance, especially into eliminations when our batteries weren't quite as recharged, and you get into bigger pushing battles than that. It had like a noticeable effect where in some matches we were disabled for over 3 seconds from our log files. We kind of tracked through it what our voltage level was and what our outputs were. And when you're playing a competitive match and you suddenly go dead in a pushing battle, it really did have an effect. Or with us, especially having a wheeled shooter, we'd be under pressure and our shooter would suddenly spin down and not be at speed. So that's our real concern going forward. Unfortunately, we were a little slow getting our feedback into first about it, so we just got that in today and haven't had a chance to really discuss it with them yet, and we're hoping to get some feedback on it over the next few days and have more information by the time we get to the SWAT symposium in a few weeks.
Yeah, but other teams at the event were having the same issues. So
yeah, Ruckus had 4 teams running with the beta test hardware, and it was something that everyone was experiencing, and other teams we've talked to have had the same sort of issues.
Yeah, we've had some good discussions with 971 and 254 about this, and they noticed the same sorts of things. And now, a pro in all of this is that the new control system allows extensive log of voltage, of current, and we can see what's really happening. So we have a lot of data that we can provide, that we're providing back to FIRST, and hopefully we can see something here. Because I think the concern is that high-end teams will be able to use logging and institute fancy code to shut things down to protect themselves from the impact of these brownouts. But a rookie team who's just default code could be hit pretty hard.
Sorry, we were just running over to check Chris's question for him. Question from the Q&A. On the PDP for the RoboRio, PCM, and VRM, are the fuses interchangeable with breakers, or are they a different size? they look. We just ran and had a quick look, and they're smaller. They're more like car fuses. So it doesn't look like something that you could just pop a resettable breaker into very easily. But sorry, that's just a very quick run over in the middle of it. We can look into that some more for you later, Chris. Resources. Here's some resources you can go to. There's the control system overview, our Facebook. Oops, I forgot to put a link to the first forums on here, but there's a discussion up on the first forums as well about the beta test. And we've got some emails down there if you want to contact us with any questions you have now or throughout the season. My personal one, and then our controls one that our entire controls team looks at periodically. Well, that is the end of our slideshow. So if there's any more questions for the Q&A, thanks for all the ones we got along the way that were, I think, pretty well from our end. But if anyone has any more questions, we can stick around for a bit and answer them for you. We're not getting anything here. James, you got anything on your end?
Nothing's showing up on Facebook or on Twitter. We know there's a little bit of a delay, so we'll wait a couple seconds here. But any final thoughts, guys, on your experiences with the control system, overall feel?
Really impressed with it. We were involved in the 2009 one as well, and just everything from the functionality of it out of the box, how easy it was to set up, and the support we've been getting, and feedback from first. Things have gone really smooth this time, and we're really impressed with it.
I think in general, the control system, when it was introduced in 2009, a lot of teams had issues with various components of it and whatnot, but first improved it year after year, and there was a noticeable improvement from 2012 to 2013. And it seems like a lot of things that people were frustrated with about the old control system, the 2009 to 2014 version, has been fixed. So it really seems like feedback's been listened to, and I think this is going to be a good control system for a good season.
We do have a question coming in. Is the brownout threshold hardware limit, or could it be adjusted by software by the developers? We don't know. We don't have access into a lot of that, but it does, from the way the discussion's going, it does look like it's something that's software-based. The real question comes into how low can it really go before you just be shutting the RoboRio down anyway. So that's part of the questions we've posed to first in our report, and we're hoping for some feedback on that. Question coming in. Could you speculate on how brownout protection could be handled in code? We've got access to all of your current draws, your voltage, your temperature. Like, with that information, our hope is that if it does stay where it is, that using that information to kind of throttle back when you're getting close to the threshold instead of waiting to hit it will be a good way to do it. Another one coming in. Talk about the current monitoring of the PDM channels. You create an object of the power distribution panel class, and you just ask it get current on any one of the output ports on it. So far we haven't used this on any of our code. We did switch to a 6-sim drive for Ruckus to test that out, and our thought was that if we ran into problems, we would start using that current monitoring to throttle back if we started hitting thresholds where we trip breakers, but it worked well enough without any throttling that we didn't get to it. We did, however, we've been using all that information, dumping it into log files throughout it, along with temperature data off of our motors and breakers and that to kind of get a feel for it. So we've been logging it every cycle. It seems pretty accurate. Right now there's a bit of a bug in the version we have where if there's no draw on it at all, it reads at about 2 amps. But they've said that's fixed for the actual production run of it, and just said like once it actually gets a draw, it reports accurately. It's the same. Is it the same 40 amp breaker? If not, does it seem to be trip quicker or slower? Same breakers. At least what we've used right now, as we said before. We don't know what'll come out in the actual game rules for 2015, but in all of our testing, we've been using the same action breakers as previous years.
But it wasn't the breaker tripping, it was the...
Yeah, no, the issue with brownout had nothing to do with breaker trippings. We didn't trip any of our breakers on the PDP. It's just a threshold that you hit, and the RoboRio just disables all of your outputs. Opinion on 6Sim Drive after Ruckus? Worked well for this robot. Again, every year's different, but we didn't have any major issues with it, and some teams that beat us by a bit at Champs used it, and it seemed to work well for them too. But yeah, we were pretty impressed with it.
Yeah, turning seemed better.
Yeah. Anything else? Karthik, anything coming in on Twitter or?
No, it looks like the questions on social media have not been coming in, so I think we're going to call this one a night, guys. So I just want to thank everyone who's tuned in for all 6 episodes of the Simbot Seminar Series, or if you just tuned in for one or whatnot. But this is going to be the last episode for right now. However, we are open to, if there's other ideas, to doing these presentations, whether it be during the build season or competition season. We really like this technology, and we're really open to providing tutorials and resources out there for first teams. We have one question that just popped in. Will you have Simbot Evolution at Swapposium? Yes, it will be there, and the new Victors, the 2 of them that we have, will be on board. So with that, I think we're going to call it a night. So thanks to everyone who tuned in. Thanks for being here, and good luck. And we will, see you all at kickoff. Have a good one, guys.